Oumuamua, an enigmatic interstellar object that captivated attention in late 2017, is set to collide directly with Earth in just 2 weeks. This cosmic event is particularly terrifying because Oumuamua shows no signs of decelerating. Scientists are concerned about the possibility of space probes sent from distant civilizations, similar to those sent by humans such as Voyager and New Horizons. Aobi, an expert in plasma physics, has suggested that Oumuamua might have been an alien spacecraft. However, there are challenges in achieving this goal, such as the immense distances in space and the time required to ensure the probe arrives before their civilization collapses. Despite these challenges, the arrival of Oumuamua in 2017 sparked excitement among scientists who had been waiting for an interstellar visitor like it. In 2017, Thomas Zurban, NASA's Science Associate Administrator at the time, announced the confirmation of interstellar objects like Oumuamua, sparking immense interest among astronomers worldwide. Just 2 years later, another interstellar object, 2I/Borisov, was spotted. Unlike Oumuamua, Borisov had the typical features of a comet with a distinct tail and coma. By studying Oumuamua's brightness as it moved through space, astronomers deduced its dimensions and shape. Oumuamua's journey is traced back to a possible close encounter with 4 stars, with a red dwarf star HIP 3757 being its closest pass. This revelation left astronomers wondering about Oumuamua's origin. Did it originate from there? Or has it been drifting through space for millions of years? The solar system is like a bustling neighborhood with planets, asteroids, and comets orbiting around the sun in tight loops. In 2017, Oumuamua entered our cosmic neighborhood, moving at a blazing speed and barely affected by our gravity. It was first noticed on October 19, 2017, by astronomer Rob Wary from the University of Hawaii. However, catching a glimpse of Oumuamua was not easy due to its tiny size and rapid movement. The Hubble Space Telescope and other powerful observers captured stunning images revealing Oumuamua as a mere speck against the vastness of space. As Oumuamua speeds away heading towards the constellation Pegasus, it fades from our view, disappearing into the depths of the Kuiper Belt, a region beyond Neptune filled with icy objects. Some speculate that Oumuamua might be an alien probe, while others think it's just a dead comet stripped of its gases over billions of years. Oumuamua's fleeting visit has left astronomers and space enthusiasts captivated, sparking debates and fueling our curiosity about the mysteries of the cosmos. Oumuamua, a mysterious interstellar visitor, has been the subject of various theories and observations. Some suggest it is a fragment of nitrogen ice, while others propose that cosmic rays interact with surface ice in interstellar space, freeing hydrogen gas trapped in water molecules. Astronomers Obi and Shmuel Bialy from Harvard University have suggested that Oumuamua could be a solar-powered spacecraft, explaining the peculiarities observed in this interstellar visitor. The true size and shape of Oumuamua remain unknown due to the lack of a detailed photograph. Astronomers rely on its brightness and knowledge of how asteroids and comets reflect light to estimate its size. Some scientists doubt the comet theory as no coma or tail has been observed around Oumuamua. Another theory involving sunlight suggests that Oumuamua's observed movement could be due to solar radiation pressure. They speculate that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese Icarus probe and NASA's NanoSail D2. These light sails use photons' kinetic energy to propel themselves through space. Conventional rockets won't catch up to Oumuamua as it heads towards the outer solar system. However, sending small robotic probes with sails hurtling towards it at high speeds could be feasible in the future, with projects like Breakthrough Starshot aiming for this. Studying Oumuamua's visit can prepare us for future encounters and better examine other intriguing objects currently in view. If the Oumuamua space probe returns, it would prompt further considerations and preparations, including building a Killian shipyard and considering the steps we should take if the asteroid space probe returns. One suggestion is to send a craft after the asteroid probe, but the challenge is immense. Oumuamua is traveling at a hyperbolic excess velocity of 5 astronomical units per year, surpassing anything humanity has launched into space before. The concept of wormholes poses significant challenges, including collapse, links to other universes, and the lack of construction knowledge. In 1935, Albert Einstein and Nathan Rosen introduced the concept of wormholes within the framework of general relativity. They proposed the existence of Einstein-Rosen bridges or wormholes, theoretical passages connecting different points in space-time. These wormholes could potentially create shortcuts, reducing travel distance and time across the universe. Although Einstein's equation suggested the possibility of wormholes, none have been observed or confirmed to date. Some equations even hint at the presence of wormholes associated with black holes, but verifying this is challenging. At the heart of this concept lies Einstein's theory of spacetime, which he envisioned as a fabric encompassing the entire universe. According to Einstein, the interaction of mass and energy warps this fabric, creating valleys that influence the motion of celestial bodies like planets and stars. This manipulation of spacetime forms the basis for gravitational effects rather than a direct force of gravity. Einstein and other scientists have proposed the existence of various types of wormholes categorized based on their properties. Traversable wormholes, non-traversable wormholes, one-way wormholes, white hole wormholes, two-way wormholes, interuniverse wormholes, and interuniverse wormholes. The exploration of wormholes remains a captivating subject, blending theoretical physics with imaginative possibilities. The burning question is where these wormholes in our universe are. While theoretically they could exist within black holes, white holes, and other massive celestial bodies, they remain largely theoretical. This uncertainty is not uncommon in the world of science, and just because something is theoretically possible doesn't mean it's guaranteed to exist. Einstein's theory of general relativity provides a solid mathematical foundation for the existence of wormholes, but theories are still subject to interpretation and further investigation. While we may dream and speculate about wormholes, their elusive nature reminds us that there's still much to uncover and understand about the vast cosmos. Understanding the mysteries of wormholes is crucial in the quest for knowledge. The most plausible explanation is rooted in the Big Bang Theory, which suggests that the universe began with a colossal explosion, scattering matter in all directions. Over millions and billions of years, this matter merged to form the universe we know today. Some speculate that these holes are interconnected by cosmic strings, forming a network of wormholes waiting to be uncovered. Unlocking the secrets of wormholes is essential to understanding the mysterious nature of our universe. For example, in Star Trek, wormholes were only visible when someone approached them, and finding a stable wormhole was rare. If true, it could mean that all galaxies are connected by the cosmic strings mentioned earlier. Wormholes or openings in space that connect different areas are often considered to exist without interference due to the natural pull of gravity. However, if wormholes were created during the Big Bang, they may have closed up over time due to the forces at play in the universe. The cosmic strings could be a reason why some wormholes persist, providing the energy or matter needed to keep them open. A stable wormhole is a dream that ignites excitement and curiosity among science fiction enthusiasts and scientists alike. To understand and harness the power of wormholes, there are several intriguing ideas, such as creating a launch pad on the outskirts of the asteroid belt, the warp bubble, or constructing a warp engine. However, constructing a warp engine faces numerous hurdles, including the need for negative mass, which remains a mystery in the cosmos. The Hubble Space Telescope captured images of 2I/Borisov, a comet that hails beyond our solar system. Scientists are fascinated by its origin and what it can teach us about the wider universe. The comet's features resemble those of the materials that formed our solar system, making it a remarkable object. Its swift movement, traveling at an astonishing 110,000 miles per hour, makes it an attractive target for space exploration. Scientists predict that Borisov will pass Jupiter and then vanish into the depths of space, never to return. This sets a ticking clock for NASA and other space agencies as they race to unravel more about its composition and behavior before it bids farewell. Hubble stands ready to monitor whatever unfolds next with its advanced sensitivity and resolution. Although scientists are eager to gather more information about 2I/Borisov in the coming months or years, we already have some clues about its nature. We have identified it as a comet, a significant detail that helps characterize this interstellar traveler. One key indicator of its cometary nature is its coma, which is the hazy cloud surrounding the comet as it travels through space. Determining the comet's size has been more challenging, but current estimates suggest the nucleus range is from about 1.4 to 6.6 kilometers in diameter. In essence, 2I/Borisov behaves like a typical comet found in the universe, except it is hurtling through star systems and happens to pass close to our own. Oumuamua, a comet with unique characteristics, was discovered by a team of astronomers in 1977. The Voyagers and New Horizons probes were sent out to explore the vastness of space beyond our solar system. The Voyagers first zoomed toward Jupiter, using its gravity to catapult them onward to Saturn. At Saturn, their paths diverged, with Voyager 1 venturing towards the unexplored realms of interstellar space and Voyager 2 continuing its journey through the outer planets en route to Uranus and Neptune. With each encounter, the fuzzy specks in the distance transformed into vivid worlds, offering profound insights into the mysteries of the cosmos. Voyager captured amazing images of Jupiter's complex jet streams, revealing swirling patterns within patterns. It witnessed the otherworldly spectacle of Io's volcanic eruptions, a moon warped by gravitational forces, and Europa's enigmatic icy surface concealing a hidden ocean. 2 years later, Voyager 1 ventured towards the cosmic unknown, while Voyager 2 pressed onward. They encountered Uranus, a peculiar planet tilted on its side, presenting a mesmerizing blue-green hue and faint rings. Then it journeyed past Neptune, a serene world marred by tumultuous hurricanes swirling in its atmosphere. As Voyager 1 bid farewell to our planetary neighborhood, it turned its cameras back towards home, capturing an iconic family portrait of our celestial siblings. Earth, a mere speck of light amidst the vastness, was famously described by Carl Sagan as a pale blue dot. No other spacecraft has ventured as far or witnessed as many wonders. In January 2006, NASA's New Horizons spacecraft embarked on an epic journey toward the distant world of Pluto. This incredible spacecraft marked the first human-made object to ever come close to the icy dwarf planet. To reach the outer edges of our solar system and fulfill its mission, New Horizons had to travel through the risky expanse known as the asteroid belt. Among these celestial wanderers, New Horizons encountered a small but significant asteroid named 13252 for APL in June 2006, zooming past at a distance of 63 million kilometers. New Horizons seized the opportunity to test its instruments, despite some not being fully operational at the time. After navigating through the asteroid belt, New Horizons set its sights on the colossal gas giant Jupiter, arriving in 2007. The spacecraft captured breathtaking images of this majestic planet. As it approached, Jupiter's immense gravitational pull acted as a cosmic slingshot, propelling New Horizons to even greater speeds and redirecting its trajectory towards Pluto. As New Horizons continued its journey towards Pluto, it encountered the vast and intricate beauty of the Kuiper Belt, a region populated with icy bodies and remnants from the early solar system. This distant frontier holds significant clues about the formation and evolution of our planetary system. The Kuiper Belt is home to many small celestial objects, including dwarf planets like Eris and Haumea, as well as a myriad of icy comets. Studying these objects provides valuable insight into the primordial material that coalesced to form the planets. Pluto itself, once classified as the 9th planet, has been redefined as a dwarf planet in the wake of the International Astronomical Union's decision in 2006. Despite its reclassification, Pluto remains a fascinating object of study. New Horizons' close flyby on July 14, 2015, revealed a world of striking geological diversity, including towering ice mountains, vast plains, and a complex atmosphere. The spacecraft's data showed that Pluto's surface is much younger than previously thought, with evidence of active geological processes and a dynamic climate system. The mission also provided insights into Pluto's largest moon, Charon, which presents its own intriguing features. Charon's surface is marked by a dramatic canyon system, possibly formed by tectonic activity. The large, dark region known as Mordor Macula suggests a history of complex chemical processes. These findings contribute to our understanding of the interplay between celestial bodies in the outer solar system and the mechanisms that govern their interactions. In addition to its work on Pluto, New Horizons has continued to explore the Kuiper Belt, providing data on several smaller objects, including 2014 Mu-69, also known as Arrokoth. This object, observed on January 1, 2019, is a contact binary with two lobes connected by a narrow neck. Arrokoth's shape and surface features have given scientists new insights into the early stages of planetary formation and the conditions of the early solar system. The information gathered helps us piece together the conditions under which our solar system, and others like it, formed. New Horizons is not the only spacecraft making headlines in the quest to explore distant realms. The James Webb Space Telescope, JWST, launched in December 2021, has been providing unprecedented views of the universe. Positioned at the second Lagrange point, L2, approximately 1.5 million kilometers from Earth, JWST is designed to observe the universe in infrared wavelengths. This capability allows it to peer through dust clouds and observe the formation of the earliest galaxies and stars, offering a glimpse into the universe's infancy. JWST's advanced instruments, such as the Near-Infrared Camera, NIRCam, and the Mid-Infrared Instrument, MIRI, are capable of capturing detailed images of distant celestial objects. Its observations have the potential to reshape our understanding of cosmic phenomena, from the formation of exoplanets to the nature of dark matter and dark energy. The field of astrophysics continues to evolve rapidly, with each new mission and discovery adding layers to our understanding of the cosmos. Projects like the European Space Agency's Gaia mission have been mapping the positions and motions of stars in our galaxy with remarkable precision. Gaia's data has revealed new insights into the structure and dynamics of the Milky Way, including its spiral arms and the distribution of dark matter. Moreover, the study of gravitational waves, detected for the first time by the LIGO Laser Interferometer Gravitational Wave Observatory and Virgo collaborations, has opened a new window into the universe. Gravitational waves are ripples in spacetime caused by massive objects, such as merging black holes or neutron stars. Their detection has confirmed predictions made by Einstein's general theory of relativity and provided a novel way to observe cosmic events that are otherwise invisible. As technology advances, the possibilities for space exploration and astronomical observation expand. Future missions are planned to explore the outer reaches of the solar system and beyond. For instance, the Europa Clipper mission, set to launch in the 2020s, aims to study Jupiter's moon Europa, which is believed to have a subsurface ocean beneath its icy crust. Understanding Europa's potential for habitability could offer clues about the presence of life elsewhere in the solar system. Similarly, the Dragonfly mission, set to explore Saturn's moon Titan, promises to provide insights into the prebiotic chemistry that may be akin to the early Earth. Titan, with its dense atmosphere and liquid methane lakes, presents a unique environment for scientific investigation. These missions and technologies represent just a fraction of humanity's ongoing quest to explore and understand the universe. As we continue to push the boundaries of space exploration, each discovery brings us closer to answering fundamental questions about our place in the cosmos, the origins of the universe, and the potential for life beyond Earth. The future of space exploration holds exciting possibilities, from interstellar probes to advanced telescopes, and promises to reveal even more about the mysteries of the universe.